And we're here for the Unit 8 review for the Math 4 class. I was commenting in class that I found it funny that all of a sudden I start seeing all of these memes showing up in my social media that have to do with statisticians. So anyway, number 1, probability that a marble is not green chosen from this bag. And of course we need to know the total, 2 plus 3 plus 4 plus 1. 10, and so that would be a 6 out of 10 chance that it is not green. 2 plus 3 plus 1 would be 6. All right, probability that multiple of 3, well, multiples of 3 where dice are concerned would be 3 and 6. That's 2 out of 6 possible outcomes. Probability that the sum of 4, 8, and 12 are rolled when the 2 dice are rolled together. I'm going to pause and put up that little chart on the right. Okay, we have our little chart here where we've got the sum of 2 through 12, which is rolling 2 dice. And then this is the ways that it can happen. There is 1 way to make a 2, there are 6 ways to make a 7, and so on and so forth. So we go back with this and we say, all right, I want to roll either a 4 or an 8 or a 12. And so I see that there are 3 and 5 and 1 ways to make that. So there are 36 possible outcomes in rolling 2 dice. So that would be 9 out of 36 or 1 out of 4. Now, probability that a 4 or a red queen is drawn from the deck. We do know that there is the 4 clubs, 4 of diamonds, 4 of hearts, 4 of spades. There are 4 out of the 52 cards. That would be a 4. The word or means that we're going to add these guys. A red queen would be queen of hearts, queen of diamonds. There are 2 out of the 52, and there's no overlap between these two, so nobody got counted twice. So we have a 6 out of 52 chance of drawing one of these 2 cards. That would reduce down to 3 over 26. Now, one of the things that we learned in, I forget exactly which section it was, A, B, or C, but one of the topics was the idea, I want to say it was A, I think that we did this, that probabilities always have to add up to 100%. So if you have a 6 out of 7 chance of making it, you have a 1 out of 7 chance of not making it, because those two add together to make 7 out of 7. Cow pie bingo. I've been looking forward to this one. 1,000 equal squares, $5 a piece. Winner gets 1,000. Egbert decides to buy 10 tickets. Find his expected value. And so basically he either wins or he loses. If he wins, let's see now, that is 10 out of 1,000, which would look like this as a decimal. And that means that 990 out of 1,000 would be his chances of losing, which is going to look like that. And then his expected value, if he wins, he gets the $1,000 less the $50 he spent on 10 tickets. So 1,000 minus 50 would be 950. Which is going to do that. And meanwhile, if he loses, he just loses the $50 he spent on the tickets, which is going to come out looking like that. Whoops. 1 decimal place. And that is going to be negative. So by the time I put those two together, I get negative 40 bucks as an expected value. But honestly, these kind of raffles like this, you know that you're going to have a negative expected value. But most of the time, you're doing it for charity. Now, you know, this brings up an interesting question at this point. If he had just bought one ticket, his expected value would have been a lot less. But because he bought 10 tickets, you know, he actually lost money for every ticket that he bought. Yes, he has more of a chance of winning it, but it's still a ridiculously small chance. And then there's the fact that he spent 50 bucks instead of 5. So, you know, buying more tickets into a raffle like this may increase your chances of winning, but not by as much as you think. You know, we're talking about 1 out of 1,000 versus 1 out of 100, which means that your chances of losing just went from 999 out of 1,000 to 99 out of 100. That is technically an improvement, and even by a factor of 10, but it's still, you know, it's still have a 99% chance of losing, even with 10 tickets in your hand. So anyway, all right, let's move on. Here, what if, and I'll be honest with, well, I think what I intended here, there are some problems with this problem, that there is something that I am ignoring here, and I'm going to ignore it on purpose. Well, there's the prospect of, you know, if he had 10 different tickets, what if he got first and second place? But that is something that we have not studied yet. That is a whole different level of statistics. And so I'm going to, for the moment, ignore that outcome, which is kind of unusual for me. Anyway, so he has 10 out of 1,000 tickets, or 0.01 for his, you know, if he takes first place. Now, if he gets second place, that, you know, we're presuming for the moment that he didn't get first, so he still has his 10 tickets. But now, because a first place winner has already been assigned, there are no longer 1,000 tickets. Now there are 999, which by the time you run the decimals on this, it's not that, it's like 0.01, 001, 001, 001, and so on. So, you know, it's a little bit more, but not by much. And so if that's 0.1 and that's 0.1, then this has to be 0.98. That's that adding up to 100% thing that we talked about. Now, let's look at the money. If he wins first, he gets 1,000 less the 50 bucks that he spent on the 10 tickets. So that's going to be $9.50 there. Here, if he gets second place, he gets the 500 less the 50 that he spent. That's going to be $450. That's going to be $4.50. And then here he's just losing $50, which means that he will technically lose 49. Now, by the time we put these together, that's going to make $14 to the good, 49 to the bad, which is going to be negative $35 expected value. Now, at one point, you may look at that and look at the last one and say, wow, you know, his expected value turned out, it's still pretty stinky, but it's not as bad as the last one. And, you know, you look at the fact that there were 2 chances to win instead of just one. That's what kind of changed things here. But still, his chances of winning are still really, really, really low. 1 out of 100 at best. All right. Norbert cleans swimming pools for a living. He's making a bid on the local YMCA. The cost of putting together the bid is $500. He could make $12,000 if he makes the bid. So let's see now. That could be, well, this is basically a win or lose situation. Now there are 3 other bids besides his, which means there are a total of 4, and they all have an equal chance of winning. So out of the 4, there's a 25% chance he'll get it. 75% chance somebody else will. Now we look at the winnings here. If he wins, he gets the $12,000 less the 500 he put into the bid, which is going to be 11,500. Over here, he just loses the 500 he spent on the bid. So now we figure out what they are separately. I'm going to do this. I'm going to pause and do this. All right, so that's what those two numbers should look like multiplied. 2875 and negative 375, which is going to leave us with 2,500 to the good. Now again, I'll point out that if you notice on these that involve businesses, like doing bids and that sort of thing, I always ask you to calculate the expected value, but I never ask for a judgment call on it. Is this a good idea or not? Well, I mean, obviously, if it's negative, it's a bad idea. But if it's positive, right now you're talking about, yes, the expected value is $2,500. Yes, he could get a $12,000 contract out of this, but there's a 75% chance that he'll walk away with a $500 hole in his pocket. Now the question becomes, is he solid enough in business that he can afford to lose $500 and not have a problem with his company? And these are questions that you don't know because you're not the business owner. So I can't begin to ask you to comment on that because there are too many variables involved in running a business for you to be able to figure out, is it worth the risk of losing $500? For some that's, pocket change, and they don't mind losing that much if they could get a $12,000 bid. The $2,500 expected value seems to suggest that, this is a fairly decent idea. It has merit. But again, you have a 3-to-1 chance of losing $500 on this whole thing. Can you afford it? So that's why you'll notice me ask the expected value, but I don't ask you if it's a good idea or not, unless it's like some sort of like a dice game or something like that. Then that's something a little more relatable. Now this is basically the same problem, but instead of 3 other people, now there's 4 other people, which means that my percentages just changed. If there are 4 other people, that means there are 5 total bids, which means he has a 20% chance of winning and an 80% chance of losing. Now, the numbers down here are largely the same. He wins, he gets 12,000 less the 500 that he spent on the bid. And that is going to be 2,300. And then over here, he loses his $500, which is going to be negative 400. And so by the time you put them together, you get 1,900 for your expected value. And you look at the 2, and yes, this is a lesser expected value, but the bottom line is that he has more of a chance of losing here. He has an 80% chance of losing his $500, whereas the last one was 75%. So, again, it depends on just how well you can absorb a $500 loss like that. All right, now we're getting into real estate again. Remember, the idea is that 3% of the commission for listing it, she gets that. If she lists it, she gets that anyway, no matter who sells it. But somebody does have to sell it. And then, she could make an additional 3% if she's the one who actually sells the place. So probably what is a good idea first is to come over to the side and figure out what is 3% of 200,000, and that would be $6,000. And so there are 3 possible outcomes. Either Bertha sells it, or another realtor sells it, or it does not sell. Now, by her estimate, 40% chance she'll sell it, 30% somebody else, and 30% not sold. Now we got to figure the money. If Bertha sells it, she gets both a $6,000 for listing and $6,000 for selling it. That's $12,000 less the $2,000 in advertising. So 12,000 minus 2 would be a $10,000 payday. This is why people get into realty. Now, if somebody else sells it, she still gets the $6,000 for listing it. that's minus the $2,000 in advertising, so that she would have a $4,000 payday if somebody else sold it. And then last but not least, if it doesn't sell, she's spent her $2,000 in vain. And so we multiply these. This becomes 4,000. This becomes 1,200. This becomes negative 600. And so that 4,000 and 1,200 is 5,200 minus 600 is positive $4,600 expected value. So again, that sounds pretty good as a expected value. There is also the fact that there is between the 40% of her selling it and 30% of somebody else selling it, that's a 70% chance that she will walk away with a check of some sort. It's either going to be a $10,000 check or a $4,000 check, neither of which are too shabby. So, the numbers seem to be in her favor on this one. It would be worth the $2,000 because she's got a 70%. That's almost a 2 to 3 or 2 to 1 odds of getting it back and then some. So anyway, now here we have the similar idea, but the numbers have changed a little bit. Here she's selling vacant timberland for $250,000, but it's only going to cost her $1,000 for advertising. I guess she doesn't have to do an open house because it's out in the middle of the woods. And so 250,000, and you ask what is 3% of that, and the answer is 7,500. So whether Bertha or another, or it doesn't sell, her perception changes here. She only thinks there's a 20% chance she'll sell it, 50% chance another agent will sell it, and then 30% it won't sell at all. So she thinks it'll sell, she just probably won't be her. And that's something in real estate. There are some people that do well with houses, but not with vacant land. I've mentioned my brother-in-law in Asheville, and that's where his specialty is vacant land. He'll do a property worth a couple of $1 million, and he'll set him up for the rest of the year. All he needs is one. So anyway, so if she's making 7,500. If she sells it, she gets 7,500 for listing and 7,500 for selling it. That's 15,000. Less the 1,000 in advertising, that's $14,000 right there. Now, point 2 is going to make 2,800. Now here, she gets the 7,500 for listing it, less the 1,000 in advertising, that's 6,500. And half of that is going to be 3,250. And then if she doesn't sell it, she loses her 1,000 in advertising, which is going to be negative 300 here. And so by the time we put those two together, 2832 is 6,050 minus 300 is 5,750. And that is to the good. So, when we're talking about expected value, when she compares this at 4,600 and that at 5,750, this one actually sounds like the better deal. I would suggest there are two things contributing to that. One is the higher price of the property, and two, the lower cost of the advertising. So both of those are contributing to her profit margin. All right, Albert is putting on a golf green, and he is accurate to 75% when he putts within 10 feet. So he has a putt within 10 feet or less on 7 holes out of the 18 holes on the golf course. So there are 7 events here, 7 holes. And what is the probability of making exactly 3 out of those 7? Well, he's 75% accurate, which means he misses 25% of the time. That 3 goes here, 7 minus 3 goes there. And so the rest of this becomes an issue for Desmos. Now I'm going to try and do the split screen here. Yeah, we can do the split screen here. And so you have 7, 3, and then 0.75, and then 0.25. And then we'll go back in and add the exponents. That is to the third power. And I have noticed this when I hover over here and it gives me the little hand instead of a cursor. This is the thing that if I click it, it will X out the whole box and I'll have to start over again. So that I think I finally figured that out. I'll click here and then just arrow to the right. And then I can do a to the b, the fourth power, and there's my decimal. All right, so it is 0.057, and then the 6 has a 7 after it, which means I'm going to bump that 6 up to another 7. Well, when you think about it, he makes 75% of his putts. 75% of 7 is going to be roughly 5. So making exactly 3 means that he's having a bad day. And so they're saying it's only a 5.5% chance that he'll have that kind of a bad day. All right. Yeah, let's move on to the next one. This one says no more than 3. That means that we're going to do 0, 1, 2, and 3. So we will do 0, 1, 2, and we've already done 3. So we don't need to run the calculations on that. We'll just borrow our work from the last page. 75% accurate. 25% chance that he'll miss. And then we put the 0 there, the 1 there, and you can see the pattern going down. 7 minus 0, 7 minus 1, and you can see that pattern going down. That's right, the last one we didn't have to fill out because it was 0577. Now this one, we are going to need to add these when we get done. No more than 3. It's going to be all of these added together. So let's do the split screen again, and let's see what happens. We replace that with a 0, that with a 0, that with a 7. Oh boy, we get 4 zeros and a 6. That 6 is going to bump those last 0, 0, 0, 0, 1. All right, let's go in and just change the numbers on each one of these. Do the 1, make that a 6. And we get 0, 0, 1, 2, which the 2 actually bumps up to 0, 0, 1, 3. And then we do the last set, 2, 2 there, 5 there, and we get 0, 1, 1, 5. And then this is where if you have some old school adding in columns skills, this is to your benefit. 1 and 3 is 4, 9, 16 with carry the 1. 1 and 1 is 2, 3, 7 is 10, carry the 1. 1 and 1 is 2, and 5 is 7. And then all of this row is zeros. And so that is no more than 3. Okay. All right, Gerbert the fisherman. Gerbert catches fish 40% of the times that he casts. And so if he casts 12 times, well, 12 events, what's the probability he'll catch exactly 9? Now stop and think about this for a minute. 40% of 12 winds up being something like about 5. So you would typically expect him to catch 5 fish. Him catching 9 fish is going to be a bit unusual. That's his lucky day. He ought to go out and buy a lottery ticket after that. So he is 40% successful, 60% unsuccessful. That 9 goes here. 12 minus 9 goes there. And then we need to get to Desmos and change some of these numbers around. And then this is a 0.4, and that is a 9, and this is a 0.6, and that is a 3. All right, 0, 1, 2, and then 4 with a 5 after it becomes 0, 1, 2, 5. The 5 kicks the 4 up to the next 5. So to put it differently, that's about 1 out of 80. That means he would make 80 fishing trips like this, and only 1 out of the 80 would he be lucky enough to catch 9. You know, if he stays true to his average. All right. So now we ask, what about catching at least 9? That means 9, 10, 11, or 12. Well, you saw what 9 was like. You can begin to guess what the rest of them are going to be like. And that's going to be parenthesis, parenthesis, and then that was 0, 1, 2, 5. All right, let's work the rest of these. 12, 10, 12, 11, 12, 12. And he is 40% successful, 60% not successful. That 10 goes here, that 11 goes here. We can see the pattern. 12 minus 10 is 2, 12 minus 11 is 1, 12 minus 12 is 0. And so now we take a trip to Desmos. And most of these are in place. I just have to change that number to 10, a 10, and a 2. I go 0, 0, 2, 4, 9. The 4, 9 bumps up to 0, 0, 2, 5. 0, 0, 2, 5. All right. Then we change to 11, 11, and 1. And we get 0, 0, 0, 3. Now you look at this pattern here. Guess what's going to happen on the last one? It's going to be so low that we're probably going to have 0. We do need to check it though. Whoops. 12 and 0. And sure enough, 4 zeros followed by a 1. That's not going to bump it anywhere. So by the time we add these together, 5, 5, and 3 make 13. Carry the 1. 2 and 2 makes 5. And the 1. And so we're looking at 1.5% chance of catching at least 9 fish. Like I told you, 40% kind of means that, you know, he's going to have to get really, really lucky to get up there. Okay. All right. Last one. Hubert has a dice game. We're rolling 5 dice, which means that we are going to have to account for 6 outcomes, 0 being one of them. 5 events, 5 dice. And we're going to have to go around that way. Okay. Now we have, if we're rolling for a 6 on one die, that's a 1 out of 6 chance, which means there's a 5 out of 6 chance it won't happen. there we go. Then we put in our exponents, the 0, the 1, the 2, the 3, the 4, the 5. 5 minus 0, 5 minus 1. We see that pattern coming. And so now we are ready for Desmos. All right. 5 and 0, huh? And this is going to be 1/6. I'm going to do the fraction because if you try and go to decimal, you'll get a repeating decimal, which means that you're going to lose something as soon as you try and plug it in that way. Same thing here with 5/6, and that is raised to the 5th power. And I get, and again, because I'm doing this with expected value, I'm doing further calculations on it. So we're just going to do 3 decimals instead of 4. Yes, 4 would be more accurate, but I don't think we're going to lose that much right now in accuracy. And a 1 and a 4. And there's also 402. I think we've seen this before. We had another problem where we rolled 5 dice, and there was both 40% chance of rolling nothing and 40% chance of rolling 1 of what we wanted. Yeah, Mama, you might want to reach for your squirt bottle because the cat's not. Oh, it's all the way over there. Never mind. Let's just say Monkey is exploring and Ubi is about to pick on her. All right. Anyway, let me get back to math. Interruption by the cats. We have, let's see now, we need to go to Desmos and keep plugging in numbers. That's a 2. That's a 2. And that's a 3. Which gave us 161, really. The 07 marks moves up to a 1. And then we come over here and we do the 3, and a 3, and a 2. We get 032. And then we do a 4, and a 4, and a 1. We'll get 003. And once again, you can look at the trend here that we're probably going to have zeros for the last part, but we're going to punch in our numbers and just to make sure our suspicions are correct. Sure enough, 3 zeros followed by a 1. That 3 zeros is not going to bump up. All right, so we got to add all of the, oh, that's right, we got to multiply them by the payout less the cost. All right, so if he gets none of the dice appearing as a 6, he loses $2, and it already cost him $2 to get in. That's $4 he's lost. Now, if he gets $1 for each one, he gets $1 for 1/6, but it cost him 2 to get in the game, so he technically lost $1 there. Now, if he gets $2 for 2 6s, he still paid $2 to get in, so he broke even there. He'll have to get 3 6s in order to make money on this one. 3 6s would be $3 less the 2 means that he makes $1, and you can kind of see the trend here where that is going. Now we multiply each of these. As it turns out, these guys multiply to make negative $1.61. This guy, -1, you can leave the decimal right where it's at, 40 cents. Times 0 is 0. Times 1 is going to be 3 cents. Now, times 2 is going to be 006, which is going to take that middle 0 and bump him up to a 1, so you get 1 cent on the deal. and then times 0 is going to be 0. So we are adding all of those together. You've got $2.01 to the bad here between these two, and you got 4 cents to the good here. By the time you put those two together, that's negative $1.97. Now, hang on, it costs $2 to join the game, and your expected value is you'll lose $1.97. Yeah, that doesn't sound like a really good game. And so we're going to move down to the fair price question. And remember that fair price is equal to cost plus expected value. That was $2 to get in, and then a negative 197 as expected value. That leaves you with a positive 3 cents as fair price. So if you wanted to charge a fair price to get in, it would have been 3 cents, not $2. Needless to say, Hubert is making some money off of this game if he can convince anybody to play it. So that is what those should look like. The fair game question you will see on at least 2 out of the 12 on the test this weekend. So.